Understanding CountDownTimer in Android, does it create a new thread for handling ticks? Unpacking Android's CountDownTimer. In the Android ecosystem, managing timed events or tasks is a common requirement, particularly in apps that depend on scheduling operations or need to perform repetitive actions. One of the primary utilities for this purpose is the CountDownTimer. The CountDownTimer class in Android allows developers to create a countdown timer with two main callback methods. One triggers on regular intervals, or ticks, and another one triggers when the countdown is completed. This makes it a handy utility for various scenarios, like creating a stopwatch or a countdown to an event. Does CountDownTimer create a new thread? An interesting aspect for Android developers to understand is how CountDownTimer operates under the hood, specifically whether it creates a new thread to handle these ticks. Contrary to what some might assume, the CountDownTimer does not create a new thread. Instead, it operates on the same thread where it was created, typically the main UI thread. This design decision is crucial for several reasons. Simplicity in UI updates. Because CountDownTimer operates on the UI thread, it allows for straightforward updates to the UI directly from within the onTick callback method without the need for complicated thread management or inter-thread communication. Avoidance of concurrency issues. By remaining on the main thread, CountDownTimer prevents common concurrency issues that arise with multi-threaded applications, such as race conditions or the need for synchronization. Performance considerations. Operating on the main thread means that CountDownTimer is naturally limited by the capabilities of the UI thread. This limits the use of CountDownTimer for tasks that are not lightweight or require high accuracy, as excessive operations may cause the app to become unresponsive or lead to ANR, app not responding, errors. Best practices for using CountDownTimer. Given its operation on the main thread, it's important for developers to adhere to best practices to ensure smooth application performance. Minimize workload. Keep the work done in the onTick method as light as possible. Expensive operations should be offloaded to background threads using mechanisms like async task, with caution as it's deprecated, or executor service. Consider alternative timing tools if your application demands a reliable timing mechanism, especially one that functions while the app is not in the foreground or operational for extensive durations. Consider alternatives like Handler, Alarm Manager, or Work Manager that facilitate background processing more efficiently. Manage the UI responsibly. Since CountDownTimer directly affects the UI, make sure to handle configuration changes appropriately to avoid memory leaks or crashes. Consider using ViewModel to handle lifecycle events in a more managed way. Understanding the functioning and threading model of CountDownTimer is crucial for Android developers looking to leverage this utility effectively while maintaining optimal app performance. By doing so, developers can harness its power for time-based functionalities while keeping their applications responsive and robust.